Hello everyone, welcome to the channel CSC Scholar Studies. In this lecture, I will discuss the minimization of DFA, how we perform the minimization of DFA. So, what are the concepts behind the minimization of the DFA? For one regular language, many number of DFA can be constructed, but the minimal number of state of DFA is exactly one. Means there are possible many number of DFA can be constructed for any particular regular language, but the minimal state of DFA is exactly one of any particular language. So there are two different methods which used to minimize the DFA. First is the state equivalent method, and second is the table filling method. The transition table. This is the example of transition table. What is the transition table? In transition table, we draw the table among the state and input. Suppose there are different set Q0, Q1, Q2, Q3. These are the state and the inputs are A and B. Here we fill the transition table according to the given DFA. Suppose Q0 is any state, and for A input and B input, the transition is go to at Q1. So from Q0 state for A transition, we go at the Q1 state, and for B transition also go at to Q1 state. Here we can fill according to the DFA all the row of the transition table. This is a method which used for the minimization of the DFA. Equivalent state to state Q1 and Q2 are said to be equivalent if for all input x belong to sigma, the transition function is from Q1 state the input symbol x, and for Q2 state input symbol x is set both Q1 and Q2 said to be equivalent if either go at the final or non-final state. Suppose any transition x from any state, suppose Q0, and another transition is from x and it goes at 1 and it is good at Q2 state. Both the Q1 and Q2 said to be equivalent state, and we can merge into Q1 Q2 state. So when the transition of two input symbol is same at different state, then the both different state we can merge and set to be equivalent state. We will more clear when we solve the examples. So these are the important points for the minimization of DFA. We remember these points at the time of solving the question. First is a minimization algorithm detect equivalent states. We have identified which are the equivalent states at the time of minimization. Next is a before applying minimization algorithm eliminates all inaccessible states from the given DFA. And next point is a any state is non-reachable from the initial state, then it is known as the inaccessible state. मीन्स हम व्हेन जब हम स्टार्ट इनिशियल स्टेट से ट्रांजिशन स्टार्ट करते हैं और किसी स्टेट पे नहीं पहुंच पा रहे, तो वो इनएक्सेसिबल स्टेट होगी और उसको हम लोग रिमूव कर देंगे एट द टाइम ऑफ मिनिमाइजेशन. नेक्स्ट पॉइंट इज अ मिनिमाइजेशन एल्गोरिदम आर एप्लीकेबल ओनली फॉर DFA.